Hi guys. I just want to just getting started here just before I suppose I kick into this, and I just have probably a few questions for you. I can see that there's probably 9 of you there online, 8 or 9 of you online. So I just want to just make sure that a few things are working. You can see that's actually a live chat in the side of the YouTube panel here, and I just want to just ask you a question through this number of questions. I suppose first, can everyone hear me? First question. Okay, so let me just ask that question there. So I'm just going to send that through there. Maybe you can just type back there if you can hear me okay. I'll just give that a moment or two just to make sure that this is transmitting the audio. Okay, I'll just give it a moment. And Megan, hi Megan. So you can hear me fine. That's brilliant. Okay, so I now know that the audio is definitely transmitting. Second question is that when I look at the screen here, my screen is inverted. So I suppose my question is this: can you see the screen? Okay, is the screen fine? So can you see the screen? And I suppose maybe I should write something on the paper here. I could just going to actually write down hello. Okay. So the question now for me is, when you read hello, does it read correctly? Okay. So can you see the screen? And does hello read correctly? I'll just give that a second now, just see can I get a response on that. Neve, yes. Oh, brilliant. Okay, so the inverted screen here is just on my view, and it's not on your view. Well, that's brilliant to hear. Hi Neve, hi Megan, hi Joanna. I have about 9 people here now. It's just 2 o'clock, so maybe what I should do is I should just get started here. I suppose the next session that I will have, I'll probably do something, sort of a dual display in relation to, I'll use YouTube for the, hi Viola, I'll use YouTube for the live feed, and I might suggest that we could also use Teams if people actually wanted to ring in, okay, and they actually wanted to ask their questions. One of the, I suppose, the downsides of actually using there's not really a system that sort of well, I haven't got a system here at home that integrates all of this into one place. So one of the downsides is that YouTube has live chat, but sometimes live chat is a bit slow in relation to trying to take questions and so on. So I suppose my question to you should be here is, should I get started? Should I get started? I'll just type that in there. Should I get started? The plan was to have a look at the mock in-class multiple choice exam that Jer sent around. I had got a couple of questions from students in relation to questions on that exam, but maybe what I'll do is, I suppose this is my question to you now, is should I just start this question by question and just try to go through this and try to put a little bit of clarity on actually what's required? So that's a question for you guys. If you are happy for me to start the process, well, then I'll start the process. Okay. So let me just get rid of this hello sheet. And maybe what I'll do is I'll get started now. Okay. So what Jared's done is he's given me, I've got a copy of it here. So he's given me a CA assignment. It's a mock in-class multiple choice exam. What looks like the date for this, so I'm not too sure what way he's going to run this. But it seems like it's on Wednesday, the 4th of April, from 3 p.m. to 4:15 p.m. Percentage of total marks, it's worth 50% of your total marks, and there's 1 mark per question. And there's I suppose there's 30 questions on this particular assessment, and what you have to do is you have to answer all 30 questions. And it seems to be there's a lot of questions on here in relation to some of the basic stuffs like scales of measurement and so on. But maybe what I'll do is I'll just flip the page, yeah, and I'll just start going through each one of these questions and see can we actually figure out what's going on here. So question 1 is, and I have to keep an eye on the chat there as well. It's just in case. Yeah, okay. So Joanna, question by question, that's what I'll do. Yeah. So question 1 is Ophelia, Irma, Harvey, and Katie. Or Katia are the names of 4 hurricanes during the 2017 season. Given only these data, what would this level of measurement be called? Okay, and maybe I'll just reflect on that for a moment. So our scales of measurement, right? So every variable, don't forget, is a variable is simply a question that you ask, and when you ask that particular question, there's responses to the question. And when you look at the responses, when you take any two individual responses, and when you compare them to each other, if you can do certain things with that comparison, well, then they fall into certain levels of measurement. And the certain levels are what's known as nominal, ordinal, interval, and ratio. Okay? And the key thing about nominal variables, yeah, that's the questions that you're asking, is that when you look at any two responses, there's no natural ordering to them. For example, if I ask somebody what is their gender, okay, well then there's someone responded with male and someone responded with female. There's no way to order them. There's no way to say that males are more important than females or that females are more important than males. Yeah. So variables where there's no natural order to the responses, yeah, are called nominal variables. And actually, you can probably see in this question here is that I suppose the question that was asked was, what are the names of the hurricanes? Okay? Or can you give me 4 names of hurricanes? And the names were Ophelia, Irma, Harvey, and Katia. And I suppose they're just names. They're just I suppose qualitative categories. Yeah, they're just names, and there's no natural order to them. Yeah. I suppose technically you could probably say that Ophelia was more powerful storm than Irma, which is more powerful than Harvey, which is more powerful than Katia. But just from a pure perspective, they're just people's names or their names of hurricanes, and they fall into what's known as the nominal scale of measurement. Yeah. Scales of measurement, the ordinal scale of measurement is where you can actually rank things. Yeah. So where one thing is more important to something else. Technically, the responses to the questions are still categories, yeah. But as I said, there's an order to them. So, for example, if you were to ask someone to rank their teacher on a scale of, let's say, very bad, bad, indifferent, good, very good, well, then you can see that there's a natural order to them. Very good is more important than good, and so on. And that scale would be what's known as an ordinal scale. Right? So the difference between ordinal, nominal, and ordinal is basically, well, first of all, they're typically categories that are given back, yeah. Okay? But with nominal, there's no natural order to them, and with ordinal, there are a natural order. Now, there's a little bit more complication in relation to ordinal because you can get numbers back as well, but they're purely categories. The interval scales are when you ask a question and you get a number back. Okay? So, for example, if I was to ask how many brothers and sisters have you got, you can see someone will say 0, 1, 2, or 3. So once you get numbers back, they're either at interval or ratio. And the best way to differentiate between interval and ratio is ask yourself the question, if someone responded with a 0, does 0 actually mean the absence of the condition? Okay? So what we actually have here is in the ratio, you can see there's an O, yeah? So that means that with ratio, the 0 really means the absence of the condition. So for example, when I ask you how many brothers and sisters have you got, if you respond with 0, that truly means you have no brothers and sisters, yeah? Okay? If I ask you how much have you got in your bank account and you respond with 0, that truly means you have no money in your account. As opposed to another, let's say, variable where the response is numerical. So if I was to ask you the temperature that water freezes at, you might say 0 degrees Celsius. But does 0 really mean the absence of temperature? It doesn't, yeah? So in that case, temperature is measured at an interval level and not a ratio level. Okay? But that's just to highlight that there's every variable, every question you ask, there's a meter stick that's used in relation to how we measure it, yeah? So to get back to this question 1, you can see that the 4 hurricanes have names: Ophelia, Irma, Harvey, and Katia. And names are nominal. Like the way, what's the name of the type of car that you're driving? You're either driving a Mercedes, you're driving a Ford, you're driving a Toyota. They're just names. There's no way to order them yet naturally. Yeah? Okay? So they're all nominal. Okay, so hopefully that explains that. So in relation to the first question, I'd be saying it is a nominal variable. Yeah. Okay? The second question here says the following are a set of waiting times for a sample of calls to a customer service helpline. Okay? So you can see that basically what we asked was, we asked 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We asked 13 people, effectively, the question. And the question was, how long did you have to wait when you phoned up Aircom or when you phoned up Tree to get to an actual customer service helpline? The first person said 3 minutes, 7 minutes, 13.5 minutes, 40 minutes. The fifth person said 16 minutes, and so on. Okay? But the question that's being asked here is, what is the range for this set of scores? Yeah, so what is the range of this particular data set? And the range is a measure of dispersion, okay? And the range is basically the distance between the largest observation. So it's the largest observation minus the smallest, okay? And that tells us the maximum distance between people, yeah, or their responses. And you can see in this situation here, if I'm not mistaken, the largest observation seems to be 32. Okay? Actually, these seem to be ordered, brilliant. So the largest is 32 and the smallest is 3. So in this case, the range is 29. Okay? So what we're saying is there's 29 units between the person that gave the smallest response and the person that gave the largest response. Okay? And that's a measure of dispersion. Yeah, it's one particular measure of dispersion. Okay? So in this case, the range is 29. So I'd be going with B. Okay? Now, if I'm going too fast, just tell me there in the chat. Just tell me to slow down a little bit. Okay? I just have to just check something here for a moment, guys. Just 1 second. Oh, that's just another meeting there I got invited to. I'll just ignore that. Okay. So question 3. So the order of these questions now aren't really following the order that the material was presented to you in the class, yeah, okay, or in your lectures. So they're a little bit mixed up. So I'm going to be jumping from some, let's say, foundational topics, yeah, into things that are a little bit more complicated as I'm going through these questions. But let's have a look at the next question here. So this is question 3, and it says the average sum of squares, yeah, the sum of squares divided by the number of participants is commonly called, okay? And we've got a number of options here, okay? At the range, the mean absolute deviation, the variance, or the standard deviation. So let's actually just look at that for a moment. So the sum of squares, yeah, okay, is typically the distance between an observation, okay, and the respective mean. So if this is a sample, if it's a sample statistic, it's the square distance between each observation and the sample mean squared. And we do that for all observations, okay? So we sum that up. So this is the sum of squared distances, yeah, okay? But what we're going to calculate is the average of them. So what we're really going to do is we're going to divide by how many observations we have, yeah, okay? Actually, technically I'm dividing, because I'm using a sample, it's n minus 1, but it's still an average that I'm calculating. And actually this formula here is the formula for, this is what we call the variance. Anytime you divide by how many things you have, you're calculating an average. So look, we're roughly dividing by how many things we have less 1, so we're still calculating an average. And what is this? This is the average squared distance observations are away from the mean value. And we actually call that the variance, okay? So the variance is the average of the sum of squares. So in this case here, the variance is the average of the sum of squares, yeah? If I was to get the square root of this, okay, all over n minus 1, I'm dealing with the sample in this case, okay? In this case, the square root gets rid of the square from a linguistic perspective, yeah? So the square root cancels with the square. So now I can sort of ignore the square root and I can ignore the square. And now what I have inside, yeah, is I'm dividing by how many things I have, and it's a distance, okay? So now this is the average distance observations are, away from the mean value, okay? Which is the square root of the variance, yeah? Which we call the standard deviation, right? So that's the standard deviation, right? Okay. So that's what D would be. And in this case, this isn't what we're looking for. We're not looking for the average, we're not looking for the, I suppose, let me just check this here for a moment. Yeah, so the average sum of squares, yeah, okay. Well, the average sum of squares is commonly called the variance, yeah, okay. But the standard deviation is, I suppose, it's, although I'm using it linguistically, the square root to get rid of the square, it also has an effect on this. So it actually reduces the sum of squares as well. But let's not worry too much about that. The mean absolute deviation is simply, okay, so let's say the mean absolute deviation, MAD, yeah, is simply the absolute distance between the observation and the mean value, okay? See, sometimes the observations are less than the mean, in which case when you take the mean away from you get a negative value. And sometimes the observations are bigger than the mean, which means when you take the mean away from the observation, the value is going to be positive. So what the absolute value does is it throws away the sign. So if we were to do this for all observations, well, then what we're getting here is the absolute distance, yeah? Sum of absolute distances that observations are away from the mean. But we divide by how many there are, yeah, which gives us a mean of it, which is called MAD, or the mean absolute deviation, which is what B is. And A is the range. Well, the range is what we discussed in the previous question. But in relation to this question, question 3, the average of the sum of squares, just as it says, is, well, there's the sum of squares. We're dividing by how many things we have, so we're calculating an average. And this formula is the formula for the variance. Yeah, so that question is in relation to questions. The answer to question 3 would be part C. Okay? So guys, hopefully that helped you there with that. So I'm just going to move on. Is that okay to move on? I'm just going to move on here. I'm now looking at question 4. I'll just get rid of this page here now. Okay. So I have been asked to just go through this question by question. So look at question 4 now. And question 4 is temperature in degrees Celsius an example of what kind of data? Okay. Once again, actually, let me grab this back. Okay. Once again, what we have here is, okay, so if you ask a person, I always like to go back to what the variables represent. So if you were to ask a person what's their favorite temperature, yeah, okay, now most people wouldn't say, probably wouldn't say 0 degrees Celsius, yeah, or -2 degrees Celsius, but who knows, yeah. But temperature in degrees Celsius is an example of what kind of data, okay? Well, let's say we asked a few people that question. Some of their responses, yeah, okay, could be 5 degrees Celsius, 20 degrees Celsius, 0 degrees Celsius, -10 degrees Celsius, who knows, yeah, but it ranges into the negative values and up to the positive values, yeah, if that makes sense. So the key thing here is that the responses are numerical, okay? Also, we can add them together, okay, to give us a total degrees Celsius. We can calculate the distance between them. The distance between this person and this person is 15 degrees Celsius, so that makes sense. So these are real numbers that we can work with, okay? But the question we really need to ask ourselves is, does 0, if someone responded with a 0 on this scale, does it mean the absence of the condition? And as I said earlier on, 0 degrees Celsius doesn't mean that there's no temperature, okay? So in this case here, it's not a ratio scaled measure, because ratio with the O in it means that it has a real 0, and it must be an interval scaled measure, okay? So in this case here, I'm going for interval, okay? Is everybody okay there with that question number 4, and the rationale behind why temperature is actually measured on an interval scale and not a ratio scale? Okay? So let me maybe just refresh on that for one more moment. Okay? When you ask a question, you're measuring a variable, you get responses to it. In this case, it's temperature. So if I ask the question, what temperature, what's your favorite temperature? I could get responses. And a valid response would be 0 degrees Celsius, because it is a temperature. Okay? So now if I focus in on that value, yeah, when someone responded with the 0, and if I ask, does 0 degrees Celsius really mean that there's no temperature? Well, in this case, it doesn't, yeah? Okay? It doesn't mean the absence of temperature. So in which case, we're dealing with an interval variable. If 0 did mean the absence of the condition, well, you see ratio has the O in it, okay? The O is like the 0, okay? So this is the absence, okay? Whereas this has no absence, yeah, okay, of the condition that's being measured. Okay? So let's just get that here. So Dean, hi Dean. So if it was €0, would it be ratio? And that's a great example of actually a variable that's measured on a ratio scale. So for example, if we ask the question, how much money have you got in your bank account? Some people might say €100, some might say 10,000 euros. Somebody might say -€200 because they've overdrawn, yeah. And someone might say €0. So Dean, as you suggested there, in that case, if someone did respond with €0, it really means they have got no money, if that makes sense. So it's the absence of money. So in that situation, which is a classic example of something that's measured on the ratio scale, because the 0 is really it means that it's a real 0. So hopefully that helps you out there. Yeah, Dean, that's correct. That's a good question and a good example. Yeah, in relation to something that's at the ratio level. Just moving on here, we have in question 5, an owner of a car dealership is interested in what car model is sold most frequently in order to maintain adequate stock levels. Sorry, guys, you'll probably hear my dog as well in the background there. Yeah, letting off a little bark. Anytime someone goes by the window or the door downstairs, yeah, he lets off. Sometimes he goes a bit crazy. Yeah, but look, sure, that's we'll just have to deal with that. So apologies. So let's get back to question 5. An owner of a car dealership is interested in what car model is sold most frequently in order to maintain adequate stock levels. Which measure of central tendency is this car dealership owner really interested in? Well, he's interested in the model that's sold most, so most frequency. Most, mo means the mode, yeah, okay? So actually, the modal response is the response that's most frequent, yeah, okay? So in this situation, the answer to that question is the mode, yeah, okay? Okay, so hopefully that answers that. So when it comes to the things that are most frequent, we're talking about modal responses, the most frequent responses. So in this case, he's looking at the most frequent model of car. So the proper scale of measure or measure of central tendency is the mode. And the question is also asking us for a measure of central tendency. So the median, the mean, and the mode are all measures of central tendency, but the standard deviation is a measure of dispersion. So we'd exclude the standard deviation straight away. So then we're left with the mean, the median, and the mode. Well, the mode, as I said, is the most frequent. The median is the middle, M and the I for the middle, yeah? And the mean is the typical average, although there is many different ways to measure a mean value. Right? So in question 5, we're dealing with the answer is the mode, yeah? Question 6. Okay, I have to sort of let's go into the back of my mind in relation to my Excel skills here, yeah? You have a data set in Excel containing a nominal variable, okay, which you want to put in tabular format. What set of steps should you follow? I don't know here yet, to be honest with you. What do you want to put it into tabular format? Okay, you have a nominal variable. So in which case it's a nominal variable, yeah. So there's no natural order to them, yeah. So the histogram is out, yeah, because a histogram has a natural order to them, yeah. Okay. I'd say probably what you'd go for is maybe just a column chart. Yeah, that would be it. Yeah, it wouldn't be a pivot table. Yeah, it would be a column chart, and none of the above. So I'd be going with a column chart. To be honest with you, here, I suppose I probably should just really leave that question 6 to yourselves and to go into Excel and just have a mess around with some of them things to see what happens. But I suppose the important thing here is that the variable is at the nominal level of measurement. Okay. And if you think about, for example, okay, if I asked people, let's say their gender, okay, I might get something like, some people said male, some people said female. Now, obviously, gender is a complicated question nowadays because there's many different. I'll just put down other here, okay, because maybe people want to respond with some other gender, and the frequency is, let's say 5, let's say 10, and let's say 2 people responded with other, which gives us a total of 17 responses. I could do a bar chart for this, okay? I could put male here at 5, I could put female at here at 10, and I could put other at 2. So this is male, female, other. But there's nothing to stop me from doing it the other way around, okay? Putting female here, male here, and other here. So there's many different ways that we can permute this from a bar chart perspective. Which is the point I'm trying to make. A histogram is ordered, yeah? So in a histogram, the values go from the smallest here through to the largest. So there has to be a natural order associated with them. So histograms are only used for, question 6 is A, okay? So thanks, Joanna. Okay, so question 6 is A, is a pivot table, yeah, okay? Okay, so it's a pivot table, yeah, okay? Which you want to put in tabular format. Okay, well, there you go. So the answer is A here. So if it's A, well, then I better stop talking about that question. So I'm looking at column charts here rather than histograms. I suppose a column chart might work as well in this case. But let me not spend any more time on that. You obviously know more about that than I do in relation to Excel. So let me just maybe move on to the next question then. So what we have here is the following are the ages of participants who participated in a market research study. So once again, this variable that's being measured, the question that was being asked is, what's your age? Yeah, okay, 56, 26, and so on. And what we're being asked here is to calculate what is the median age. So in relation to calculating the median, okay, from raw data, okay, so this is raw data, it's not in tabular format. The first thing we need to do is we need to order the data. Okay? So we need to order the data from smallest to largest, or largest to smallest. So let me just actually order this data here. So you can see the smallest value seems to be 18. Okay? The next smallest value seems to be, if I'm not mistaken, okay, seems to be 26. Okay? And there's another 26 over here. Okay? Then the next smallest value is 27. There's two 27s. Okay? The next smallest value then seems to be, if I'm not mistaken, seems to be 41. Okay? The next smallest value then seems to be 35. Okay? The next smallest value then seems to be 36. Okay? The next one then is it 38? It is. It's 38. Okay? The next smallest value then is 42. I have 42. I'll just move this over here. Next smallest value then that we have in this data set is 56. Okay? That's that. And then the final value in the data set is 72. So to calculate the median, what we do is we triangulate in. So we cross off the outliers. So this is actually a good thing about the median, is the median gets rid of outliers immediately. So the median is a good measure when your data set is skewed, because skewedness in your data set is an indicator of outliers. But you can see when you're calculating the median, what you do immediately is you cross off outliers. Yeah, you cross them off one at a time, pairs of outliers on either side. So we keep crossing off like that, one over here and one over here, until we're left with either two in the middle or one in the middle. So depending on whether the data set has an odd number or an even number of values, yeah, even case, which this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 observations, an even number of observations, an even sample size. Every time we cross off two, we'll be guaranteed to be left with two in the middle. So what we're going to do is we're going to calculate the average of them. So it's 31 plus 45 divided by 2. And what does that give us? Excuse me, that gives us 66 divided by 2, which is 33. And 33 is halfway between these two values. So that's what the median is. So in this case, we have the answer to that question would be 33. Right? So it's part C. Yeah. So hopefully that helps out there. I've seen that there's a question later on, yeah, which asks us how to calculate the position of the median value. Okay? So we'll come back to that now in a moment. Yeah, and the question is actually is in relation to when there's an odd number of values. Okay, let's have a look at the next question. Question 8. The following are results for a master's thesis from a class of 10 people. So 10 people submitted their master's thesis, and here are the results. Okay, and the question is, what is the mean thesis result? Okay, now let's just assume this is sample data, just from a symbol perspective. So this is question 8. Okay, so the mean. Let's just assume X bar is the sum of the observations divided by how many observations we have. So what we're going to actually have to do here is, sorry, just 1 second. I probably should do this in my head, but just 1 second there, guys. I just want to grab my calculator here. Okay. So what we're going to do is we're going to sum up all of these observations. Okay. So just go to mode 0 here. So I'm going to sum up all the observations. Let's put them headphones back on. So we have it's 45 plus 55 plus 55 plus 58 plus 62 plus 65 plus 66 plus 68 plus 71 plus 78 gives us a total. The total sum of the observations, yeah, okay, is 623. And what did we say? We had 1, 2, 3. Well, we've got 10 observations, yeah. 10 of them. So the average here would be 62.3. So if you want to calculate the average of a set of raw data, just add up all the numbers and divide by how many there are. Yeah. Okay? So in this case, 62.3 is part C. Okay? The next question says the following are results for a different sample of master's thesis. So you can see we've got 1, 2, 3, 4, 5. And the question is, what is the standard deviation of the thesis results? So to calculate the standard deviation, we need to know the mean value. Okay, so we need to calculate the mean of that. I just want to get another sheet of paper here. Let me just move this out of the way. So we need to calculate the mean. Now, the other key part of this question here is that this is sample data. Yeah. Okay? So we need to calculate the mean. So this is question 9. Okay? So the mean, the sample mean, is the sum of all the observations over how many observations we have. Yeah. So when we sum up all of these observations, so we have 48 plus 55 plus 56 plus 57 plus 64. Okay. The total summation is 280. Okay. And we're going to divide that by 1, 2, 3, 4, 5. So when we divide that by 5, we get 56 is the mean value. Okay. So our mean is 56. Okay. So what we need to do is that what we can see is that, let me just draw a little chart here. Yeah. So let's just say the mean value is here is 56. Okay. And we can see that some people have responses. Someone responded at 48. Another responded at 45. Okay. Sorry, 55. Another responded at 56. Another responded at 57. And another responded at 64. Okay. So you can see the point I'm trying to make here is that, albeit we added up all the numbers and we calculated the average, yeah, the average is the center point, yeah, is that values are dispersed on the left. Some values are smaller than it, okay, and some values are greater than it, but all the values are a little bit of a distance away from it. So if we want to calculate, okay, if we want to calculate the standard deviation for the sample, the formula for the standard deviation of a sample is S, okay, is equal to, what we do is we take every observation, we take away the sample mean, we square it, and we do that for all the observations and add them up, and then divide by n minus 1, sample size minus 1, and finally we get the square root of that. So to do that in this situation, what I'm going to do is I'm just going to create a quick table. I'm going to list all my observations down this column. This is discrete data. Okay? It's not in categories, it's not in classes, it's not a grouped frequency distribution. Okay? So it's discrete data. So I'm just going to write the numbers down as I see them: 48, 55, 56, 57, 64. And what I'm going to now do is I'm going to calculate x minus x bar first of all. Okay? Then I'm going to square that. Okay? And then I'm going to sum that up, okay, to give me the top part of the formula here. So what we do is the first observation, the first x is, okay, x are observations, is 48. And what I'm going to do is I'm going to take away 56. So 48 minus 56 gives us minus 8. The next one is 55. 55 minus 56 is going to give us minus 1. The next one is 56. So we have 56 minus 56 gives us 0. So don't worry about that. That's all perfectly fine. The next one is 57 minus 56 gives us 1. And then what we have is we have 64. We have 64 minus 56, yeah, okay, is going to give us a value of 8, yeah. Something unusual is actually going to happen here, but let's just work it through, yeah, just from a team perspective. You'll actually see, as expected, yeah, okay, the weights on the left are the same as the weights on the right hand side, which is a consequence, yeah, of the mean being the measure of center, yeah. So but what we're going to do is we're going to square these values. So don't forget, squares of negatives are always going to be positive numbers, and the squares of positive numbers are also always going to be positive numbers. So we have minus 8 squared, minus times minus is plus, 8 eighths is 64. We have 1 squared is 1, we have 0 squared is 0, we have 1 squared is 1, and we have 8 squared is 64. And then what we're going to do is we're going to sum, because see, we need the sum of the column called x minus x bar squared. Excuse me. So what we're going to do is we're going to sum them up. So we have 64 and 64 gives us 128, and the 1 and 1 is 2, so we end up with 140 here. So we can actually calculate the standard deviation now quite easily. This value here is the sum of the x minus x bar squared column in my table. So that's what's going to go in here. So now I have S, which is the sum of the x minus x bar squared divided by n minus 1. The square root of that is going to be equal to the top. The numerator here is 140. That's what we calculate here. Divided by the sample sizes, there's 1, 2, 3, 4, 5 observations minus 1. Okay? And we get the square root of that. So that's 130 over 4 and the square root of that. So let me just do that in the calculator. So we have 130 divided by 4 gives me a value of 32.5. So we get the square root of 32.5. The square root of 32.5 gives us a value of approximately 5.7. Okay? So what we're saying here is this, is that the average of this data set is 56, but on average people are 5.7 values, okay? Scores, percentage values below or above the average. So our answer is 5.7, which is part B here. Sorry, I just have a question there. Why do we have to take away 1 from 5? Yeah, interesting question. And not to maybe, okay, if it's a quite complicated question, to be honest with you. It's so strange why it's so. In the population case, we have population and sample. Okay, so when we calculate the variance, yeah, let's say in the population case, we have a formula. It's how far the observations are away from the population mean squared divided by how many observations there are, and sum of those. Right, that's the variance. Yeah. And when we calculate it in the sample case, it's how far the observations are away from the sample mean squared all over n minus 1. So naturally, the natural thing in the population is we calculate the average squared distance observations are away from the real mean value of the population. Okay? Now, I'm not giving you the answer to this here. I can direct you to a mathematical proof that I actually have got up on YouTube. Yeah, okay, and you'll probably see it in my playlists of looking at the sampling distribution. Yeah, but now, what we know is this, is that when we continually take samples from the population, okay, and when we keep calculating from each one of, let me actually write that down here, yeah, okay, okay. So here's our population, okay. So when I sample from my population, I get a set of values, and what I can do with them is calculate their mean value first of all, yeah. And I continue, you just don't take one sample, you continually take samples, yeah, and calculate the sample means as you go along, yeah, okay. So all the way down, yeah. And what we know is this, is that if we actually look at these sample means, yeah, okay, and if we calculate the average of them, so the average of the X bars, what we know is that that value is equal to the population mean, yeah, for certain, yeah. Okay? But if we were to calculate the variances of these samples, yeah, the S squareds, yeah, okay, and when I calculate the average of them, okay, we don't get the population variance, yeah, okay. We say that the sample variance, sorry, if I divide it by n, yeah, okay, here, we say that the sample variance, yeah, is, well, this variance here is what's known as a bias estimate of the population variance. And the way we, let's say, we account for that biasness is by taking 1 away from it. And there's it's a straightforward proof, a little bit, I suppose, not straightforward, yeah. There is a proof that I have got up online that will answer that. But now, in the sample case, we always calculate our average by reducing our degrees of freedom by 1, yeah. Okay? Whereas in the population case, we calculate the average because we're dealing with all of our values. So, Viola, sorry for that. I know it's a bit of a convoluted answer, yeah. It's a very straightforward question that you've asked. Why do we have to take away 1 from 5, yeah, okay? In other words, n minus 1 in the sample case. It's a very straightforward question the way you've posed that there. Mathematically, the question is actually quite a complicated question, yeah, okay? And I do have on my playlists, yeah, I have a set playlist on the sampling distribution, yeah, which is this distribution of samples that you're taking from population. I do go through that mathematically, why it ends up as that, why the sample variance is an unbiased estimate of the population variance. Okay, so I'll direct you to that. It's probably a little bit beyond the scope, is well beyond the scope of what we're doing here, yeah. And probably on a master's master's program in statistics, you'd probably cover it, yeah. Okay, so but the point being here is question 9. The answer here is part B, 5.7. Okay. Is everybody okay so far? I have 22 people there. Some of you are pretty quiet, but maybe I'll just check in with you. So maybe it's can all just type a Y if everything is good. If you have a specific question, don't be afraid to answer, to shout the question out there, yeah, or type the question in the live chat. Is everybody keeping up so far? Or I should have really asked, are there any more questions? So, hi Mark, that's good. Okay. So, unless someone, hi Zoe, Tanya, hi, Hi, James. Brilliant. Right. So let me just maybe continue then. Right. So question 9 is what we've done there. So I'm on to question 10 now. Yeah. So uh, this question says the standard deviation of a sample of 100 participants in a research study equals 25. Yeah. So let's just keep that in mind. So the sample standard deviation, that's important. Right? We have a symbol for that. Right? It's S, and it's equal to 25. Right? And the question is, the variance of the sample must equal. Yeah. Well, the variance is S squared. Yeah. So the variance must be the square of that. Okay. So it's 25 squared. Okay. So what we do is we just get 25 and we square that. Okay. Which gives us 625. So S squared is 625. Because this is the standard deviation. Right? This is the variance. So anytime you calculate the variance, if you get the square root of it, you end up with the standard deviation. So if you're given the standard deviation, to reverse that process, you'd square it to get back to the variance, yeah, which is a natural thing in our formulas, yeah. So you can actually see that the answer here to this question is option C. Okay? Just moving along there. If there's any detailed questions required on that, maybe just give us a shout. It comes from the formula, yeah. Don't forget that S squared, the variance is the sum of the x's minus the x bar squared all over n minus 1, where that's the variance, whereas the standard deviation, yeah, is S, which would be the square. Well, how do I get S from S squared? I get the square root. So it's actually what we have here. It's the square root of that. So if I have this and I want to go back here, I should square. If I have this and I want to go down here, I should get the square root. Okay? Hopefully that's helpful. The next question here is, if you collect data from all of the items or people about which you want to reach conclusions, which of the following have you collected data from? Well, it's not random. I suppose you could have collected them randomly and still collected all the observations, yeah, okay? Well, it's not random. It's not sample. We've actually collected the population data here, if that makes sense. So in this case here, it's straightforward. We've actually collected all of the items of the people. So what we've actually captured is the population. Okay? Part B is if we took a random selection, yeah, okay? It's not frequency distribution. Don't forget, frequency distribution is simply a table, yeah, okay? That has frequencies in it and has, well, either classes or observations down here, yeah, okay? So, yeah, and we're told, so it's not frequency distribution. This is a straightforward question. When you capture everything that you're interested in, you're dealing with the population. Question 12. An example of a qualitative variable is, right? So a qualitative variable, yeah, is one where the response to the question is typically not numerical. But more importantly, it's not that it's just not numerical, because it could be not numerical, yeah. But in general, if the response is numerical, not numerical, if the response is numerical, but we can't add them together and subtract them and so on, yeah, it's not a quantitative variable. So a qualitative variable would be, well, look at this, the number of children in a family. If I ask someone how many children are in your family, the response is going to be a number, okay, and you can add them together. So this is numbers, so that's definitely not qualitative. The weight of a person, how heavy are you? Well, in kilograms, people, that's a number, so that's not qualitative. The name of a political party, well, that's not numerical, if that makes sense. So Fianna Fáil, Fine Gael, Sinn Féin, Labour, the Independents, and so on, yeah, okay? Or the whatever the coalition is, the Solidarity, the Social Solidarity Coalition, yeah, okay? So in this case, we have the name of a political party is qualitative, yeah, okay? Miles between oil changes, yeah. Well, how far did you have to travel before you had to do a mile change? That's a number, yeah, okay? And you can add them together as well. So moving on. Which of the following is not an example of discrete data? Okay? Now, discrete data is where the answers to the questions are always going to be whole numbers, yeah? Okay? So if you think about it, the number of households with a broadband internet connection. Well, you can't have half a household with a broadband internet connection, yeah, unless you're up on the second floor and you just don't get the reception, yeah. But let's just keep this simple here, yeah. So that's actually the number of households where broadband collection is a number, yeah. Okay, it's a whole number, so that's discrete data. Okay, the number of employees reporting in sick. You don't have half an employee reporting in sick, yeah, or a third of an employee. You always have a whole number of employees reporting in sick, yeah. The number of kilometers between Dublin and Cork, yeah. Well, someone could travel 6.5 kilometers. So there you go. You have a portion. You could have a portion of a whole number in there, yeah. And then the final thing is the number of students in NCI. And once again, the number of students in NCI are all whole numbers, yeah. Okay? So they're discrete. They're discrete values. But the one that's not discrete, an example of a not discrete value would be the number of kilometers, which is a continuous value, if that makes sense. Yeah? Because you can go to 6.2, 6.35 kilometers, 6.457, 8 kilometers, and so on. It has a continuity associated with it. Just moving on now to question 14. We have, for a relative frequency distribution, relative frequency is computed as, right? So let's just actually have a look at this really quickly. So a frequency distribution, okay, and I'm just going to assume that's discrete. So we asked people a question, yeah, which was how many brothers and sisters did you have? And responses were, some people said 0, some people said 1, 2, 3, and 4. Okay, and then we had how many people responded with those values: 5, 10, 15, 10, 5. Gives us a total of what we got here. We have 10, 20, 30, 40. We have 45 in total. Yeah. So what this is a discrete frequency distribution. Yeah, because the classes are discrete values down here. Okay? The frequencies represent how many people responded. So there was 45 people asked the question. Yeah. So what's a relative frequency distribution is that where we take the total number of responses and we ask ourselves, what are they as a fractional amount of the total? So every time you deal with a fraction, 1 over 2, 3 over 7, yeah, 12 over 4, yeah, these are all, although we call them fractions, yeah, okay, these are all relative quantities. 1 is relative to 2, 3 is relative to 7, yeah, okay. There's 3 sevenths, yeah, there's 12 fourths, yeah. So the 12 is in magnitude relative to some other number here. So actually, when we've always dealt with fractions, yeah, okay, we've really been dealing with relative frequencies, yeah, if that makes sense, yeah. So the relative frequencies are really the fractional amounts relative to the total, yeah. So it's 5 over 45, 10 over 45, 15 over 45, 10 over 45, 5 over 45, and we convert them to decimals by doing the division, yeah. So for a relative frequency distribution, relative frequency is computed as, yeah, well, you can see what I've done. It's the frequency divided by the total, yeah. So there you go. The class frequency divided by the total frequency, right, is what the relative frequencies are. So hopefully that helped out there, guys. And then finally we have question 15. Is a group of 100 students was surveyed about their interest in a new international studies program. Interest was measured in terms of high, medium, or low. In the study, 20 students responded high interest, 50 students responded medium interest, and 30 students responded with low interest. So if you think about it here, this question here has a frequency distribution. So maybe I'll just get another blank page. Bring that out of the way. So this question now, the question that we asked was people's interest in an international study, yeah, so a program of study, okay, and the responses were you either had low interest, medium interest, or high interest, if that makes sense, yeah, right? And what we had then is we know the frequencies, how many people responded with these categories. 20 responded with high, okay? 50 responded with medium, and 30 responded with low interest. Okay, gives us a total, okay, of 100 people. Yeah. So the question here is, what is the relative frequency of students with low interest? And don't forget, I just said a moment ago, to calculate the relative frequencies, you calculate it's the class frequency divided by the total frequency. So the relative frequencies are simply 30 divided by 100, which is 0.3, 50 divided by 100, which is 0.5, and 20 divided by 100, which is 0.2. Okay? So in this case, it is what is the relative frequency of students with low interest? So low interest is 0.3, which is part D. Okay, so I think that covers that particular question here. Yeah, there are, I suppose there's 30 questions on this paper. Yeah, so I don't know whether I'm going to get through them all. Yeah, I'm 15 minutes into this now. Yeah, guys. Yeah, is everybody okay there? Yeah, is there any questions so far? Is everybody happy enough? I probably should have actually said as well when we first came online, yeah, is I hope everybody's well. You know, things are a little bit crazy, I suppose, around the world at the moment, yeah. But I hope everybody's doing well, and everybody and their family and all are all doing well and okay. And I hope everybody's, I'm sure you are, guys, yeah, it's how important the isolation, the social distancing, not the isolation, is to get on top of this, yeah. Enough said about that. Okay, is everybody good? Yeah, brilliant. Okay, thanks, Joanna. Yeah. Oh, hi, Caitlin. Okay, brilliant. So I'm just going to move along now, okay, and let's try to get through some, hopefully as many of these as possible, yeah. So question 16 now, okay, just looking at, refer to the following distribution of mortgage repayments, yeah, okay. So the monthly repayment. So actually the question now here that was asked, yeah, was what is your monthly mortgage repayments? Yeah. Okay. 3 people said they're spending between 600 and 800 euros on their mortgage repayments. 7 between 800 and 1,000. 11 between 1,000 and 1,200, and so on. 40 people out of the total number of people, yeah, 40 people responded between 1,400 and 1,600. Actually, you can probably see, I think the important thing here as well is the total number of people that responded, yeah. And what we got, we have 10, I'm just doing these in tens first, maybe I would actually do the units, yeah. So we have 4 and 9 is 13, plus the 4 gives us 17, plus the 2 gives us 19, 20, we have 30, so I'm going to put down 0, carry the 3. Then I'm doing the tens, we have 3, we have 5, we have 9, and we have 11, we have 12, so there's 120 people, yeah, were basically asked this question, yeah, what was their mortgage repayments, yeah. And you see, the way this is now is, previously we listed down the discrete values, yeah, okay, the discrete responses, yeah, maybe I'll get that page back a moment ago, yeah, that we had, yeah. You see the responses were discrete values, yeah. But when you have so many different responses, yeah, it doesn't make sense to have a distribution that lists all the possible responses, because more than likely everybody's response here is some people have to pay, you know, 675 euros and 22 cents regularly each month, yeah, and it's variable as well. You typically, it could be fixed, yeah. So what we do is we create classes here, yeah. So this is called these are groups or classes or intervals. And you can actually see the distance between the lower bound and the upper bound is 200. The distance between 800 and 1,000 is 200. 1,000 and 1,200 is 200. The distance, all the distances seem to be, they're all 200. Which is, the question 16 is, what is the class interval? The class interval is the distance between the lower and the upper bounds, okay, typically. And in this case, they're 200, okay? So the class interval, yeah, the class interval, width, we should really say, yeah, is equal to the lowest bound minus the upper bound, yeah, okay, or the upper bound minus the lowest bound, yeah, which gives us 200 in this case, yeah. So I hope that's okay. What type of chart would best represent the frequency distribution presented in question 16? Yeah. So the best chart, yeah, we always have our frequencies along the vertical axis, and then our classes go along here, and you can see that they're ordered. The smaller classes are here, followed by the next larger class, followed by the next one, and so on. There is a natural order to them. Okay, there's a natural order to them. They're continuous. There's no gaps between them. Yeah. So the best chart to use in that case is a histogram. So we use histograms. Don't forget, I suppose the responses weren't categories. Sorry, the responses were not categorical. They weren't nominal values. Yeah. Okay. And so we don't have the option of, as I said earlier on when I showed the bar charts, we could actually present this in in a number of different bar charts. We could have low, medium, and high. We could do, well, I suppose there's a natural order to them, isn't there? So actually ignore that, yeah. But my point being here is that these responses are got to do with a quantitative variable, yeah, and they're put in categories, but there's a natural order to them, yeah, and there's no gaps between them, so it's continuous also. So the appropriate chart to use is a histogram. A bar chart is typically used for when we're dealing with a nominal variable. A scatter plot is when we have two variables, yeah, and we want to look at the relationship between them. A bivariate situation. A histogram is used when we have a single variable, and a time series plot is used when we have time. So we don't have time, we don't have two variables here. There wasn't two questions asked, yeah, and we don't have nominal data. So what we're left with is a histogram, yeah. Right? So hopefully that helps there, guys. So in this case, it's part C. Moving along. In constructing a frequency distribution, the approximate class interval width is computed as, yeah, the class interval width, yeah, okay, is, well, the class interval width is the range of the data set divided by how many classes we require, yeah, effectively, yeah, okay. So you can actually see that part A, B, and C is the maximum value minus the minimum value, maximum value minus the minimum value. So both of them are ranges. The part C is the minimum minus the maximum. It is a range, but it's obviously flipped from an it'll be negative, yeah, but still a range, yeah. If you got the absolute value of it, it makes sense, yeah. And then this one here is the maximum value, so it has to be the range, yeah. So we have the options now are A and B, yeah. A and B are options, yeah. And what we need to divide the range by is how many classes we want, yeah, okay. So not the sample size. So actually, the answer here is part A. Okay? I have a video up in relation to constructing group frequency distributions, yeah. So maybe you should watch that, and I go into that in a little bit more detail, yeah. Question 19. For a data set with an odd number of observations that have been sorted from smallest to largest, where is the median value located? Yeah. So let's just have a look at that visually. Yeah. So let's just do that. Question 19, and let's try to work this out here. Yeah. Right? So if we look at this here, let's assume, yeah, right? Let's assume that the sample size, yeah, right, it has to be an odd number of observations. So let's just start off with, we could start off with 1, yeah. Right? Let me just throw 1 away. Let's start with 3, 5, 7, and so on, yeah. Okay. So these are possible sample sizes, and they're odd, yeah. And if you think about, if we have a sample of size 3, there's 3 observations, yeah. And the median is, well, where is it? It's at the second position, yeah. Okay. When there's 5, 1, 2, 3, 4, 5, you can see that it's at the 3rd position, yeah. And when it's 7 observations, we've ordered them now, 1, 2, 3, 4, 5, 6, 7. The median is in here. It's at the 4th position, yeah, when we've ordered the data set. Okay? So it's definitely not n. So you can see that in this situation here, when n, the sample size is 3, the median is at the 2nd position. It's not at 3. Okay? When the sample size is 5, it's at position 3. So it's not. So it's definitely not n. What about n over 2? Well, 3 divided by 2 is 1.5. So you can actually see in this situation, yeah, the median is at the 2nd position, not at 1.5. So that couldn't be the case. What about n plus 1 divided by 2? Let's try that. N plus 1 divided by 2. So n is 3. 3 plus 1 is 4. Divided by 2 gives us 2. Oh, that matches. The median is at the 2nd position. What about the next one? We have 5 plus 1 is 6. Divided by 2 gives us 3. So the median should be at the 3rd position, which it is, yeah? And then we have 7 plus 1 gives us 8. Divided by 2 gives us 4. And you can see that the median's at the 4th position here. So actually, the appropriate thing here is part C, yeah? So you can probably see in this situation, what I'm trying to give you here is a strategy. Yeah, is that, look, it's okay sometimes not to know the answers to these questions straight off, but if you try to problem solve them and just rationalize in relation to what are the answers that are being provided, what are the options being provided, and try a process of elimination, yeah, you'll naturally arrive at the right answer. Right? Question 20 here is just check and see is there any questions there. No, there's not. Okay, everybody's good. Question 20 is the mean as a measure of central tendency would be inappropriate for which one of the following? ages of employees in a company. It's okay. Okay. You could take everybody's age. You could calculate their average. Yeah, that'd be all right to do. Income of liars, their numbers as well. You could add all them up and divide by how many there are. Yeah, that's all good. The number of pages in statistics books. So you could go into the library, you could take one statistics book down at a time. You could list how many pages there are. So now you have a set of numbers, which is how many pages are in the books, and you could calculate the average of them. And then finally here, the marital status of college students in a particular university. So people are either single, married, divorced, cohabiting, yeah. So you can't add them things together, yeah, and divide by how many there is. So actually, the mean as a measure of central tendency would be inappropriate for when you're dealing with marital status. Yeah, you can't add them responses together if that makes sense. Yeah. So hopefully that gets that. Hopefully that demystifies what's going on there. Question 21. Consider a set of data from a population with n is equal to 10. So there's 10 observations. The mean for this set of data is 50. The sum of squares is 6552. What is the variance? Yeah, interesting. Yeah. Let me just move this page out of the way here. Okay. So what is the variance? Yeah. Now, the important thing here is this, yeah, is that he's asked you in this question, yeah, in relation to population, right? So we also have, it's a population, okay, not a sample. So the variance is sigma squared, and it's equal to the sum of squares, x minus mu, the distance now from the population mean squared, divided by how many things we have. So he's telling us the sum of squares is 6. See, the sum of squares, yeah, is 6552. So in this case, the variance would be 6552 divided by n, which is 10, which gives us 655.2. So the variance in this case, the var, this is question 21, okay, the var would be 655.2. If he asked us, you could do this again, you could ask a different question. You could say, what is the standard deviation? The standard deviation. Okay. So he still provided you with all the information, yeah, okay? But what you would do in that case is we take it a step further and we calculate sigma, we get the square root of 655.2. Okay? Another thing you could change is instead of asking about population, okay, you could ask that it's sample data, okay? In which case we would calculate s squared, which would be the sum of squares, don't forget it's sample data, so it's from the sample mean, divided by n minus 1. So you divide by 9 instead of 10. So if he's going to be setting you as a paper and if he wants to change this around a little bit, yeah, they're the types of changes that you could make, yeah. But anyway, question 21, the answer is D. Yeah. Moving along now, we have, let's see, what is the standard deviation for the data presented in question 21? Right? So, well, there you go. Right? So the data presented in question 21. Question 21, we've just calculated the variance. Right? We calculated the variance to be equal to 655.2. Well, the standard deviation, as I said, is the square root of 655.2. Let's do that. Square root of 655.2. That gives me a value of 25.6 to one decimal place. Yeah. Okay. So that question here, which is question 22, gives us 25.6. Oh, yeah, to one decimal. Well, he gives us two decimals there. Yeah. Okay. Well, look, there is part C. Yeah. Okay. Which is that. Okay. So hopefully that answers that question here. So that was a nice follow on from the previous question, which is what we sort of, without looking ahead, is what we sort of strategized. Yeah, that would be a reasonable thing to do, is to change things up. But maybe the change that would appear now in the actual assessment that you're going to get will probably be dealing with samples rather than populations. Let's have a look at the next question. You can see, how would you describe the shape of this distribution? Well, it has a tail. There's a tail pointing in the positive direction. So this is a positively skewed distribution. So in that situation, we have a positively skewed distribution. As opposed to, it doesn't look like this. It doesn't look negatively skewed. And also, it doesn't look symmetrical, okay? So just to keep that in my mind. So negatively skewed, symmetrical. Okay? A uniform distribution would be that all the bars are the same height. Yeah, that's uniform. So it's none of them. Okay? It's actually positively skewed. Okay? Just moving along now. Question 3. Question 24. It says in the distribution displayed in question 3 above, question 23 above, which of the following statements would be true? Okay. Now, let's have a look at this here. Now, there's actually been some research done into this, this particular type of, let's say, characteristic, and it's not actually always true. So there are research papers that say that the comparison of the mean to the mode to the median doesn't always necessarily tell you the shape of the distribution, as in whether it's positive or negatively skewed or symmetrical. It doesn't always tell us the right answer. It's a good rule of thumb. So let's see. So we know that this is positively skewed. And what we know about positively skewed distribution, is this. Well, let's look at a symmetrical distribution. In a symmetrical distribution, the mean is down the middle, the median is down the middle, and the mode is down the middle. In other words, the mean equals the mode and equals the median. They're all the same value in a symmetric distribution. Now, in the situation where we have an outlier, so up here, see, the median has 50% of the data less than it and has 50% of the data greater than it. The mode is the most frequent, so it's going to be the tallest bar. That makes sense. But the mean is you add up all the data values, you add them all up, and you divide by how many there are. So imagine we had an outlier. So imagine here that we have a value out here. It's a very big value being added on to a lot of small values. And the effect is that the distribution, is going to get skewed. Well, it's meant to be skewed out there. And what happens is that the mean is pulled always in the direction of skewness. So when you make a comparison between the median, in a skewed distribution, the median is going to be less than the mean. And actually the mode as well is going to be less than the mean. That's probably a better way to actually compare these two things. So the mean, median, and mode will be the same. No, because the distribution is positively skewed. That's only true for symmetric distribution. The mean will be greater than the median and the mode. Yes, that is true. The mean will be bigger than the median and the mode. So that is actually true here. The mode will be greater than the mean and the median. No. The mode is the tallest bar. That's where the most frequent things would be. The median will be greater than the mean. No, because the mean is pulled in the direction of the outlier. So actually the answer here to that question is part B. If that was a negatively skewed distribution, well, then the mean would be pulled to the left and would be less than the median and would be less than the mode. So guys, hopefully that sort of helps you with that question there. Just wondering, is there any questions on that in relation to that explanation? Does that make sense? See, the median is just a count of values. So irrespective of whether it's an outlier or not, it just contributes to the count. And the median is half the values are above it and half them are below it. And it doesn't matter where this value is. It could be further out in that direction out here. It still counts for one of the half of the values that are on this side of the median compared to the half of values that are on that side of the median. Excuse me. Okay. So everything is good here. Just moving along here now. Okay. So it's the probability question here now. Now, has he given us totals? He sort of has given us totals. He's given us all, there's totals down here and here totals here. Brilliant. So this is what's known as a contingency table. You have two variables. You have the month down here, and I suppose across here you have the county. And the question here is question 25 is refer to table 1 above and calculate the probability that a house was sold in September given that it was sold in County Wicklow. Well, the first thing is this, is the simple probability. The probability of an event is simply equal to the number of favorable outcomes divided by the number of possible outcomes. Now, if I just wanted to know what the probability was that a house was sold in September, yeah, don't forget the total number of houses sold, yeah, was 5,131. So the probability that the house was sold in September would be, well, how many houses were sold in September? It was 463. Right? Relative to what? Relative to 5,141. Right? Now, but that's not the question he's asking. He's telling you that you're given some information. So this is a conditional probability. So we want to know what's the probability that the house was sold in September, given, okay, that the house was sold in County Wicklow. Okay? Right? So anytime you're given, like if you were in NCI, yeah, and if I asked you to go and find somebody, yeah, okay, let's say for argument's sake that we wanted to find Joanna in NCI, yeah, so, and let's say Zoe, I'm going to ask you to go and try to find Joanna in NCI, yeah. Well, you'll go and you'll start looking on the ground floor, the first, the second, third, and the fourth floor to try to find Joanna, yeah, okay? And you have a chance of locating Joanna in the building, yeah. Now, if I tell you to go and find Joanna on the third floor, well, you're just going to go and you're going to look on the third floor. So I've given you some information with respect to where Joanna can be found, if that makes sense, yeah? So in this question here, the given piece of information is that the person should be found in Wicklow, yeah? The house being sold is in Wicklow. So what we need to concentrate on, okay, what we now need to concentrate on is concentrate just on the floor called Wicklow, which is down here. We're going to concentrate on this. And now the question is, out of these people, what's the probability that was sold in September? Well, you can see that we have 119 relative to 1345. So in this case, we end up with 119 people, or 119 houses sold in September in Wicklow out of the 1,345. Yeah. So the important thing here is that anytime you're given a piece of information, you need to concentrate on that piece of information. It's either a column or a row in the table, and what you do is you just box off that row or that column and concentrate there, and then go and find out how many of these things there are in that column or that row relative to the total number of things that are in that column and that row. Okay? So in this case here, we have 119 divided by 1345, which gives us a value of 0.09, yeah? Okay? Oh, well, it's 0.088, which is 8.8%. Okay? Next question. In a distribution, the second quartile corresponds to which of these, yeah? It corresponds with the mean, median, mode, or variance, yeah? Well, let's think about it. So this is question 26. Okay. So let me just ask you here, was everybody okay with question 25? That's not my dog, yeah, that's the neighbors, yeah. Is everybody okay with question 25 there, guys? Yeah? Okay, that's all good, right? So there's no questions in any at this stage, yeah. Right? So I'm looking now at okay, brilliant, Joanna. Thanks, Viola. Thanks, James. So question 26. So we're dealing with quartiles, yeah. So if you think about it, if you have a data set, smallest values, largest values, yeah. Okay? We can split it in half, okay. We can split each half up into quarters. So this is the first, when I'm walking along in this direction, okay, I'm walking along, and what I've now done here, when I get to here, I've covered a quarter of the data set. So that's the first quartile. Yeah. Let's say that's Q1. And as I continue, this is Q2. The second quarter has been covered. Yeah. 2 quarters have been covered. And then when I continue, this is Q3. And then when I continue, I covered everything, which is the 4 quarters, total 4 quarters have been covered. Now we know the median splits the data set up in half. So the median is actually down here, yeah? Because half the values will be over here and half the values will be over here. So actually the median is another name for the second quartile, yeah? So the second quartile is what's known as the median. Okay. Let's move along there now, guys, yeah? Instead of doing just continuing percentiles, yeah? Instead of breaking things up into quarters, yeah, Okay? Well, we could do deciles. Okay? So we have quartiles. Actually, just get rid of that paper. Okay? So we could have. Sorry, just 1 second, guys. I just want to grab some more paper there. Yeah. Because otherwise, the light from the camera. Otherwise, the light from the camera will glare out the video. Okay. So what we can do is we can, as I said, we can split a line up into smallest value, largest value. We can split a line up into quarters. Yeah. We could split a line up into, let's say, into tenths. Yeah. Okay. I meant to do tenths here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, here's the line here, actually, guys. Yeah. So, or we could split a line up into, so we could split it up into quarters, tenths. We could split it up into thirds as well if we wanted. Yeah. Okay. Or we could split a line up into 100. Yeah. Okay. 100 pieces. Yeah. Okay. So when we go to quarters, this is known as quartiles. When we go to split a line up into 10 sections, this is known as deciles. And when we split it up into 100, it's known as percentiles. Okay. So hopefully that's helpful there, guys, for you. Okay. So in this case here, percentiles divide a distribution into 100 equal parts. Yeah. Okay. To locate the percentile for a given observation in a data set, the data must be, well, it must be sorted. Yeah. Okay. And sorted and listed from minimum to maximum, because that's the whole point behind this, is that the smallest values and then the next smallers are all listed down. Yeah. Okay. So there's a natural order to the data set. Displayed in a histogram, summarizing a frequency distribution. Well, we could summarize them in a frequency distribution as well. Yeah. And calculate the percentile from that. Distributed symmetrically around the mean, not necessary. The answer here, I think, that he's looking for is the data needs to be sorted and listed from the minimum to the maximum values. Yeah. Okay? And then what we do is we triangulate. We triangulate in by actually, well, not triangulate in, by, if you want to calculate the 56th percentile, okay, 56th percentile, okay, well, you start walking in that direction until you cover 56 of those intervals. Yeah. Intervals, okay? And that will give you the 56th percentile. Well, see, what that means is that 56% of people are less than you. Okay? If I continue walking and if I want to find the 95th percentile, okay, well then I keep walking in that direction until 95 of them intervals, yeah, until I cover 95 of them intervals. And what does that mean? It means effectively, yeah, that I'll end up somewhere around here, yeah, and that 95% of people have a score less than me, yeah, or equal to me, yeah, if that makes sense. Question 29. A board of directors consists of 8 men and 4 women. A 4-member search committee is randomly chosen to recommend a new company president. What is the probability that all 4 members of the search committee will be women? Yeah. Okay. Let's think about this here. Yeah. Okay. So a board of directors consists of 8 men and 4 women. Yeah. So we have 8 men, and we have 4 women, okay, which gives us a total. We have 12 people, yeah, okay, in total. So that's the total number of things that we have, and we have to select a 4-member committee. Yeah, a 4-member search committee is randomly chosen. Yeah, and what is the probability that all 4 members of the search committee will be women? Yeah, okay. Well, let's think about it. So here's our search committee. And I'm going to fill the first spot, yeah, and I want to know what's the probability, yeah, okay, what's the chances that the first person selected, yeah, will be a woman, okay. Well, how many women, as I said earlier on, the probability of an event is the number of favorable divided by the number of possible, okay. So the first person needs to be a woman, and the second person needs to be a woman, and the third person needs to be a woman, and the 4th person needs to be a woman, yeah, okay? If that makes sense, yeah. So what's the possible probability that the fourth person is a woman? Well, there's 12 people. How many women are there? There's 4 of them. Yeah, so there's 4 chances out of 12. So you've got 4 chances out of 12. Yeah. Now, when I select the first woman, yeah, she can't be selected twice or 3 times or 4 times. Yeah, we need 4 individual people. Yeah. So now there's only 11 people left. Okay. And also there's only 3 women left. Yeah. So the probability that the next person is a woman, yeah, which they need to be, well, there's only 3 women out of 11. Yeah. The next chance, the probability that the next person is a woman, well, there's only 2 women left to choose from, and there's only 10 people in total. So 2 chances out of 10. And then finally, the probability that the last person is a woman, you've got 1 chance out of 1 chance out of 9. Okay? But the important thing here is that the committee has to contain the first person needs to be a woman, and the next person, and the next person, and the next person, which is the multiplication rule. So we need to multiply all these things together, yeah? Which gives us, if you look at this, it's 12 times 11 times 10 times, it's 12 times 11 times 10 times 9. The denominator is going to be 11,880. And the numerator is 4 times 3 is 12 times 2 is 24 times 1 is 24. So you've got 24 chances in 11,880 possibles. Yeah. So let's actually do that again. Do the division. 24 divided by 11880 gives us a value of, you have 1 chance in 495. There you go. It's part D. 1 chance in 495. Yeah. Okay. To be honest with you guys, yeah, in relation to probability, I would recommend that you go to my probability playlist, yeah, okay, which deals with the addition rule and the multiplication rule, and also deals with the contingency table probabilities, yeah, okay? And have a look at that playlist, yeah, because there's a lot of different questions that we could ask from a probability perspective, and he only seems to have asked a couple of probability questions, yeah. And then this next question, which is the last question, question 30. We did actually quite well here, yeah. It's an hour and 22 minutes now. Didn't seem like an hour and 22 minutes for me here going through this, yeah. But sure, look, time flies when you're having fun, as you say. If this stuff can be considered fun, guys, yeah. So let's see. So now we're into question 30. So question 30 is there are 10 AAA batteries in a box, and 3 are defective. Okay, so you've got 10 batteries, okay? And 3 are defective. And 2 batteries are selected without replacement. What is the probability of selecting 3 defective batteries in a row? So this is like what we had a moment ago. Right? You could do this from a binomial perspective as well, yeah. Right? So we know that the first battery was defective. Okay? 2 batteries are selected without, 2 batteries are selected without replacement. Yeah, that's important. Without replacement, okay, means that when I select the first battery, there's only 9 batteries to select from for the next chance. When I select the second one, it doesn't get put back in. There's only 8 batteries to select from for the third battery. Yeah. So let's have a look at this. So 3 are defective. This is the same as the previous question, guys. Yeah. Okay. So what's the probability? We've got 10 batteries. What's the probability of a defective battery? Okay, of a defective battery. Okay. Well, for my first choice, there's 10 batteries there, and there's 3 defective. So I've got 3 chances in 10. Yeah. So now I didn't put that battery back in, and it was defective. So there's only 9 batteries left. So the next one, there's 9 batteries, okay, and there's 2 defective batteries, yeah, left. So we've got 2 chances on the second go, two possibilities on the second go to get a defective battery, but there's only 9 batteries left. Now, on the third go, yeah, the previous 2 batteries weren't put back in and they were defective, yeah. So you've only 1 defective left out of 8. So there you go, guys. So what do we end up with? And we have to get 3 defective. So the first needs to be defective, and the second and the third, yeah. So it's the product of these probabilities. So it's the probability of it being defective, that the 3 batteries are defective, is going to be equal to 10 times 9 is 90, and we have 90 times 8 gives us 720. So you've got 720 chances, yeah? So 720 possible ways, yeah? 3 times 2 times 1 gives us 6. You have 6 chances in 720. So it's 6 divided by 720 gives us, that's equal to 1 in 120. So 1 chance in 120, which is option C. Okay, guys, it's 3:30. I can hear the cattle calling me downstairs, yeah, so I probably have to run down and get myself a cup of coffee or something like that. But anyway, just to ask us really quickly, this should be available for you to go back through. And I see there's still 19. There was 19, 20, 21 people. It's great that you all stead through this, yeah. But I hope that this was helpful for you guys, yeah. I really do. I know that this can be a little bit daunting, yeah, especially the way things are going now. But I think the main thing here is just to do the drill. The stuff, albeit it might seem a little bit complicated, yeah. If you just take your time going through this stuff, yeah, you can manage to get through it. But I hope that this stuff was helpful for you. And thanks for tuning in. I'll just maybe wait for a moment to see is there any specific questions that you might have, yeah. And Viola, I hope that covered some of the questions that you had as well. Yeah. Okay, great stuff. Thanks, Viola. Thanks, Joanna. Thanks, James. Okay, guys. So if there's no specific questions, what I'm going to do is, thanks, James. Yeah, good luck with CA, everyone. Yeah. So James said good luck to everyone there with CA. Thanks, Samir. Okay, what I'm going to do now, guys, is all the best. Yeah, and actually all the best with your CA as well from me. Yeah. And look, if you have any questions, will you go to the Teams page and maybe post some more questions there? I'm going to be available. I can do another one of these sessions as well at some stage, just to get the appropriate time is the only challenging piece for you, for me, that fits in with that's not working through your other lectures that will be online. But I mean, thanks guys for tuning in, and chat to you soon. As I said, just send me questions, yeah, either through YouTube or through the team site that I've sent up. Okay, thanks guys. Bye bye.